In this first video for Conceptual Physics, I want to spend some time talking about how we use graphs to get an idea about the relationships or patterns that occur between the two variables present in an experiment, or we'll be doing it in lab activities. There are four important relationships that you want to be able to identify by looking at how the data is graphed. The study of physics is built on the assumption that nature behaves in predictable ways. There are certain laws in the universe that always will occur in a certain way. And our job as scientists in the area of physics is to discover and describe and explain these patterns so that we can then use them to predict for future events. The experiments that we will do in class and that physicists are doing all over the world are designed in order to discover the relationship between the variables involved in that experiment, the independent variable and the dependent variable. And often when you have a bunch of numbers and data, it really is much easier to understand what's going on when you plot those data points on a graph. So we'll be doing a fair amount of graphing in this class as well. So when you graph variables, the first thing you need to remember is that your independent variable goes on the x-axis, and the dependent variable goes on the y-axis. This phrase, dry mix, is the way some people use to remember which axis goes with which variable. Dry has the letters D, R, and Y, and you can use those to think dependent, which is the variable responding to what you do as an experimenter, and that goes on the y-axis. Or mix, you can use the M for manipulated, I from independent variable, and then the x-axis to make that word. You don't have to use this. I'm just offering it as one of the helpful mnemonic phrases that some people use to remember that independent variables go on the x-axis and dependent on the y. There are four types of patterns that we typically see when we graph the data from a science investigation. The first one is a linear relationship, a graph that has a straight line in it. You can also have a non-relationship or a constant relationship where there's no connection between the variables. Then there are quadratic relationships that give you curves, and inverse relationships. I'm going to look at all of these individually and give you an idea of what the graph might look like. So in a linear relationship, a change in the independent variable, graphed on your x-axis, proportionally produces the same change in the dependent variable on the y-axis. So because they're changing in equal proportions, you end up with a straight line as the results of plotting your data. And this actually is a line that you can use the formula that you may have seen in math for slope of y equals mx, m times x, mx plus b, b being the y-intercept. In this case, y-intercept is at 0. So we have an example graph over here where velocity is the dependent variable and time is the independent variable. So as time goes by, velocity is increasing, and it's increasing on a nice steady constant acceleration, giving us this straight line. Some of your linear relationships do not go through the 0 point on the y-axis, but when they do, this is known as a y-intercept or a directly proportional, and you can actually get rid of the b and the formula just becomes y equals mx. So that in this situation, if you double the value for x, you get a doubled value for y. So if we start with x at 2 and we double it to 4, well, y will go from 4 to 8. Same thing goes, to triple or to cut it in half, that the change is proportional, and since the line is originating at that 0 point of the corner between the x and the y, we don't need the b in the formula, so it's going to originate from that 0 point and then be a straight line moving up in a positive direction from there. The second type of relationship is a non-relationship or a constant relationship where a change in one variable has no effect on the other. We can change x all we want, but y remains the same. It remains constant. We can see here the value for y is 4 all the way down this table, no matter what number we're using for x. So this is creating a straight horizontal line, starting the origin being right there on the number 4 on the y-axis. So a straight horizontal line tells you there's a constant involved. You can't do anything to x that's going to change y. Y is just going to be 4. The third type of graph, shape on a graph that you might see when you plot data in class is a curved line, and a curved line indicates there is a quadratic relationship between the variables. In a quadratic relationship, the equation contains an exponent. And so you can think of it as an equation that says something like y equals ax squared plus bx plus c. A will be some number that is not zero, whereas B and C potentially could be 0. Graphs of quadratic relationships often form parabolas, as we see over here. This graph is showing how the height of a golf ball changes over time. And again, it reaches a peak and then falls in that nice parabola shape. The simplest quadratic relationship is one where the values of b and c are 0, so you end up with an equation that's just y equals ax squared. And in that case, whatever change you make to x, the square of that change is going to be made to y. So if you double the x, doubling meaning 2, then you're going to 2 times 2, you'll quadruple y. So if we double x from 2 to 4, then we're going to see 8 be 4 times larger, going all the way up to 32. Same things work if you triple x, you end up with 9 times greater value for y, or if you have x, there's only 1/4 the value for y, because that would be 1 over the 2 times 2, or 1 over 4, so 1/4 the value. And the last relationship is an inverse relationship, where an increase in one variable causes a decrease in the other, so they're going in opposite directions. In this case, whenever a change is made to x, the reciprocal, or 1 over that change, is made to y. So if you double x, if that would be 2, then you'd have 1 over 2, y would be half. Quadruple x, you have 1/4 for y, the value. If you cut x in half, well, then that is double, because x would be 1 over 2, and then you would flip that to make the reciprocal, and it would just be 2 over 1, or 2. In this case, the math result is that the product, when you multiply x and y together, you always end up with the same number. So if we looked at our chart, 2, and if you multiply 2 times 6, you get 12. If you multiply 3 times 4, you get 12. If you multiply 6 times 2, you get 12. So that the product will always be the same in an inverse relationship. This also produces a curved line, as you can see. So throughout the year, we're going to be doing experiments and collecting data for various dependent and independent variables, and then putting those data points on a graph and using the shape of the graph to identify the type of relationship that is forming between those two variables based on those patterns we see on the graph. So hang on to these notes, because you'll be using them to identify the 4 different types of relationships multiple times throughout the year.